Hello everyone. In this video, I'm going to explain question number 2 and 3 from exercise 1.1. Question number 2. Use division algorithm to show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. What we have to use? Division algorithm. Okay. So we need to show any positive odd integer. Positive odd integer will be in this form, in these three forms. So we need to show. So let's recap the division algorithm. What it is? Euclid's division lemma. Yeah. A is equal to BQ plus R, right? So let's put up on the board. So this is the question. They told that use positive odd integer will be in the form of 6q plus 1, 6q plus 3 or 6q plus 5. By using division algorithm. So now let's take, let A be, A is a variable, okay? A be any positive odd integer, any positive integer or positive integer, okay? And B is equal to, see B value, we will take it as a 6. See, Euclid's division lemma or division algorithm. What do we know? A is equal to BQ plus R. A is equal to BQ plus R. See, 6Q plus 1, 6Q plus 3, 6Q plus 5. This is like a BQ plus R form. Okay. So in the B place, what we have to take here in this question, 6 we have to take. Okay. A be any positive integer and B is equal to 6. Okay, we by Euclid's division lemma or by division algorithm, by division algorithm, A is equal to BQ plus R. This we can write. Okay, we get, what do we get if we substitute? A will be A only. A is equal to, in the place of B, we assumed it is a 6Q plus R. Okay. Here what is R then? R is remainder. How about the remainder? We always know that the remainder is either it is equal to 0 or less than the divisor. Q is a quotient, right? A is a dividend, Q is a quotient, and 6 is a divisor. So B is here divisor and R is a remainder. So how about our remainder? When we do the normal division, our remainder will be less than the divisor. So or it should be equal to the 0. Only two cases, right? It should be less than the divisor or it should be equal to the 0. So what is our condition here? R is in between 0 to 6. It is less than or equal to 6. R value is less than 6 or greater than or equal to 0. Either it is 0 or more than 0. That means what? R values are 0. We can take 1, 2, 3, 4, 5. We can't take 6, right? Because 6 is our divisor. We should go till less than our divisor. Okay. So now in this case, we need to substitute in remainder place 0, 1, 2, 3, 4, 5 and check what do we get. Okay. If R value we are taking 0, then what do we get? A here? A is equal to 6Q plus 0. Okay. So 6Q. Let's read one more time the question. What did they say? Show that any positive odd integers only, they should be in this form. Okay. Generally, odd and even integers we will discuss. Any odd numbers will be in the form of 2n plus 1. Any even numbers will be in the form of 2n. 2n is even form. Any number, if we write something into 2, for example, n you take it as a 1. Multiply with the 2, 2 ones are 2. It's a even form, right? N you take it as a 3. 2 3 is a 6. 6 is a even. So any number, if you want to show it as a even, that should be in the form of 2n. Okay. If any number, if we put in a 2n plus 1, it is a odd form. We need to remember this. No need to include these steps in the question, but we need to remember. Okay. So let's understand this. A is equal to 6q is a even form or odd form. So we need to put up this 6q, either it is in the 2n form or 2n plus 1. So I am taking here common as a 2. So what I can write, 2 3 is a 6, right? So 3q. It's like a 2n only, no? 2n form. Okay. Next, if r value is equal to 1, let's substitute. Then a is equal to 6q plus 1. So what do we can take? We should write a 2n form. Na? 2, if we take out the common, 2 3 is a 6. 3q will be left here plus 1. So this is 2n plus 1 form. Okay. Next, if r is equal to 2, a is equal to 6q plus 2. So here if we take out the 2 common, 3q plus 1. Okay. Again, this is in the 2n form, where here n is equal to 3q plus 1. If r is equal to 3, a is equal to 6q plus 3. So we cannot take out 3 as a common. We should not show like that. So we have to prove odd or even. That's the reason we will take it as a 2 only common. So, but in 3, 2 doesn't go, na? So can we split this as a 6q plus 2 plus 1? Okay. 2 plus 1 is 3 again. So now you take the 2 as a common. So 3q plus 2 ones are 2 plus 1. So this is like a 2n plus 1 form. Okay. If r is equal to 4, then a is equal to 6q plus 4. So that is equal to, if we take out 2 common, everywhere 2 only common. Okay. 2 3s are 6 plus 2 2s are 4. Again 2n form. If r is equal to 5, this is the last case, isn't it? 6q plus 5. Okay. Again, 2 is not divisible in the 5. So we will split this as a 6q plus 4 plus 1. 4 plus 1 is 5. So now we can take out 2 as a common. 2 3 is a 6 2 plus 2 2 is a 4 plus 1. Again, this is in the 2n plus 1 form. I'll show you full sum here. See, when you have taken a 0 to, see, 0, it is 2n form. Okay. Again, 1 means this is 2n plus 1. N is here 3q. 2 means, again, it is 2n form. Okay. 4 means, again, it is 2n form. But if you put odd numbers, r is equal to 1, this is 2n plus 1. R is equal to 3, 2n plus 1. Okay. So r is equal to 5, 2n plus 1. So when we put odd values, now we are getting like 6q plus 1, 6q plus 3, 6q plus 5 forms. So let's summarize this same thing. So since 6q, 6q plus 2, 6q plus 4 are even, because they are in the 2n form, remaining like integers 6q plus 1, 6q plus 3, 6q plus 5 are odd. odd form. Okay, that's it. We can conclude in this way. Let's see another sum. Question number 3. Use division algorithm to show that the square of any positive integer is of the form 3p or 3p plus 1. What did they say? Here also we need to use division algorithm only. That is nothing but a is equal to bq plus r. Square of any positive integer is in the form of 3p or 3p plus 1. Okay. Let's see how to do this. Same. In this case also same we need to take. Let or suppose a be positive integer, any positive integer, b is equal to what we have to take 3 here. Okay. 3 by division algorithm a is equal to bq plus r, we get a is equal to, in the place of b, 3q plus r. Here what is r value? R is less than or equal to 0, less than or equal to r. R is less than, divisor is 3 here, 3. That means r values are 0, 1, 2. Less than 3 means till the 2 only, just 2 cases here. Okay. So let's see. If r is equal to 0, a is equal to what? 3q only, no? R is equal to 0, a is equal to 3q. But they told square of any positive integer. So let's do square here. A square is equal, squaring on both sides, 3q whole square. 3q whole square means a square is equal to 9q square. 9q square. So what they said, in which form they said? 3p or 3p plus 1 form. Squares of any numbers, any integers are 3p or 3p plus form. So we need to put whatever the number we get, we need to put up in a 3p form or 3p plus 1 form. So let's take out a 3 common here. What do we get? 3 3s are 9. 3q square we get. So can I write this as a 3p form? 3p. Here p is equal to how much? 3q square in this case. Okay. Now, if r is equal to 1, so a is equal to 3q plus 1. Remainder is 1. But square they said. So squaring on both sides. 3q plus 1 whole square. This is like a plus b whole square form. Elaborate, I mean expand. A square, 3q whole square, that means 9q square. 2ab, 2 into 3q into 1 plus b square, 1 square. So 9q square plus 2 3 is a 6q plus 1 square is simply 1. But we need to put up either in a 3p or 3p plus 1 form. Okay, so let's take out the common as a 3. So what we get? 3q square plus 3 2 is a 6 here. 2q plus 1. So this is like a 3p plus 1, right? Here, what is p? In the place of p, we have here 3q square plus 2q. Okay. Next, if r is equal to 2, last case, a is equal to 3q plus 2. Same, squaring on both sides because they said squares of the positive integers. So 3q plus 2 whole square. Again, this is in the form of a plus b whole square. A square plus 2ab, 2 into a into b plus b square. Okay. So 9q square plus 2 3 is a 6, 6 2 is a 12q plus 4 plus 4. Okay. So in the 4, 3 doesn't go, right? So let's split this as a 3 plus 1. Same trick. Now we can take out 3 common. So 3 3 is a 9q square plus 3 4 is a 12q plus in 3 if it gone 1 plus 1. How is this? It's like a 3p plus 1 form. Here p value is whole thing, 3q square plus 4q plus 1. Seema, this is I have written like a p. So 3p plus 1 form where p is equal to this much. If we see these three cases, above these three cases, when r is equal to 0, we got a 3p form. When r is equal to 1, we got 3p plus 1 form. When r is equal to 2, we got again 3p plus 1 form. Okay. So what do we can conclude? The square of any positive integer is either of 3p or 3p plus 1 form for some value of p. So let's put up. Therefore, the square of any positive integer is either of the form 3p or 3p plus 1 for some p value. Yeah. So these type of sums are very important. Hope you people understood. Keep practicing and keep watching for more number of questions. Thank you.